So now it's a time, Volkmar Galke from Winterthur Gas and Diesel division in Switzerland. He will tell us about the engine technologies in two-stroke engines they are working with at the moment.
Yeah, thank you very much.
Please.
If you just look down your lanyards, you might see that logo, WinGo. It's not WinGo, it's WinGD. It's Winterthur Gas and Diesel. Maybe you're not very familiar with this new name. Just want to briefly introduce that to you. It's a young company with a long history. It's the future. It is a former Sulzer engines, two-stroke engines, and it was put in operation January this year. It's a joint venture between Wärtsilä, 30%, and CSSC, 70%, which is our major shareholder. CSSC, I think I don't have to introduce to you, which is a China State Shipbuilding Corporation, major shipbuilding corporation worldwide, having 130,000 employees and more than 11 shipyards. Also, Stari and Marik design companies are belonging to CSSC. So that is this part. The Wärtsilä part I don't have to introduce. But maybe what is important is that Winterthur Gas and Diesel, the name Winterthur stays for Swiss quality and Swiss innovation and Swiss engineering. So the company is fully operational in Switzerland. All the engineers are there. So the investment comes from China to Switzerland for innovations and R&D. Everything else stays also the same. All the licensees are staying the same. So we're cooperating still with Hyundai, Doosan, the ones in Japan, as you know them, Diesel United and Hitachi. Also the ones in China, like Hudong, CMD, QMD, YMCP, and so forth. I think that's all. Just to tell you that Winterthur Gas and Diesel is our new name. And there's also a nice thing, because if you go outside and you see this brochure there, it's all the Wärtsilä engines on there. It's the Wärtsilä two-stroke engine. Still, we keep the name. And with the Winterthur and the Wärtsilä, we call the engine VWX something. So the V, the W stands for Winterthur and also for Wärtsilä. So in the title, it says something about tomorrow's fuel. I took these two slides just to briefly show you what my or our assumption is. If you see the left graph, you see the gas production per region that is increasing. And also, if you compare on the right side this graph from IMF, that the fuel price for LNG will decrease. Quoting Mr. Kustas from Danaus from yesterday's Marine Money Conference in Athens, he said that fuel oil prices are not going one way. So I assume that LNG or gas will be tomorrow's merchant fuel. To be, let's say, in the right position to supply engines for this fuel, we started already, as you can see here, 1972, with the first dual fuel gas engines to develop, and it lasts long until 2013, when we introduced the latest two-stroke gas engine to the market, via passing some, let's say, developments over the four-stroke engines, and coming to the conclusion that for also our dual fuel two-stroke engine, the low pressure system or concept, like applied to the four-stroke engines, is the one which will be the standard in the future. And so we have switching from the diesel concept, when we run on liquid fuel, to the Otto concept. So Mr. Otto, you well know from the cars and the four-stroke engines, and realizing a low pressure dual fuel engine. I hope now my movie is working. Fortunately, I did it during the lunch break. You see here the principle. It's quite easy to understand. We inject the gas in mid-stroke, let's call it, and then the piston, when it moves up, compresses the gas. And the beauty of this system is that the gas is injected with maximum 12 bar, which is at high loads, and if you go lower loads, then it's also lower. So you can reduce some consumption on the fuel pump, on the gas pumps there, and then it's injected with some pilot fuel, And just to give you a short idea of what is the key technology for this concept, this gas auto concept, is this four major components. It's the micropilot system, which I just said before. It's an injector which injects the pilot fuel. Then it's ignited via a small pre-chamber. And it's nowadays we testing it still, and not let's say testing it for normal operation, but we're testing it for reducing the fuel oil consumption on the pilot fuel. And now we reached also that a consumption of lower than 0.5% on that pilot fuel. The pre-chamber technology I just mentioned before. Then there's a gas emission system. You've seen that we inject the gas on two sides of the cylinder liner, which is a different gas admission valve than for four-stroke. It's a completely separate development for two-stroke engines. And then last but not least, the engine control automation system, which is offering safety and stable operation, especially when it comes to pre-ignition and knocking sensoring. A little bit about operation. I mean, engineers, I'm an engineer. Engineers, they like this graph. I don't want to go into details on this one, but just follow the red curve. The red curve is the power. And when you see here, the red curves, I would need to, do we have a pointer? But anyway, just continue. The red curve is the power, and you see that the black one is the fuel. And if we switch from fuel to gas, the yellow one is the gas, you see that the fuel consumption goes down, and the gas consumption goes up. And then the NOx, is the orange curve, dramatically is reduced. And why I'm telling you this is because the captain or the crew, they will not recognize if you switch from fuel to gas or from gas to fuel. This is the whole idea of this diagram, that we can prove that you don't feel anything. The engine is doing it by itself. If there's anything happening on gas, it trips to diesel, so you go on diesel mode and you run on liquid. And when you start up the engine, which is by law, by legislation, you have to start the engine with the liquid. Even when the engine is idling, you can directly switch over to gas and then run the engine on gas. What's the beauty of it? The beauty is emissions. We had that already with the SCR and the scrubber presentation. With the low pressure system, so the Otto cycle, this engine is able to operate in tier 3 conditions without any exhaust gas after treatment. You see here, lowest possible NOx on gas, almost zero SOx and particles, and 25% reduced CO2. So this system is perfect for tier 3 operation. As I said before, we tested and we're still testing, and we have also the engines already now running. We'll talk about references a little bit later. But just that you know, we have a test engine in Trieste, and it's just a 50-bore engine. We're doing on a regular basis customer events. The next one is on the 12th of November. So if somebody wants to see the engine, please let me know, or Stefano. And we're happy to arrange a visit, or also to perform an engine profile for you, that you can see the engine running, and I can prove my words that you don't feel if it's running on gas or on diesel. We also have a test engine in Japan with Aioi, Diesel United, a 72-bore engine, which was really a breakthrough in the Japanese market, especially for the LNG carriers there. And this was also set up to prove that large bore engines with 72 centimeters bore are able to run on gas. With this engine, we really reached low pressure, so we went really low pressure on low loads, so on gas. 5 to 6% was possible to run that engine on gas. As I promised, some references. We have, as I said before, already based our development of the two-stroke low-pressure engine on the massive experience we have from our dear colleagues from Wärtsilä. They're having more than 1,800 low-pressure four-stroke engines in the market, and reaching cumulated running hours of 12 million. So that's impressive, and it's, I would say, the low-pressure system is the industry standard. And if you take into consideration that we started 2013 to market this two-stroke engine, we have already 33 orders clocked, and the first one will be delivered end of this year, and the next one, the 72-bore, Q1 next year. Coming to the cooperation with Wärtsilä, as I said, it's a joint venture, but also on service side, its service stays still with Wärtsilä. And Wärtsilä is now, or already did, a dedicated two-stroke service set up in Switzerland, which is the headquarter in Switzerland. So we can rely on the Wärtsilä network for spare parts and services, but also that this service is separated for two-stroke engines, so that there's no shortcome on engineers, service engineers, when it comes to a two-stroke issue. Concluding, I would say what I said is the low-pressure dual-fuel system is the industry standard based on the experience we have with four-stroke engines. More than these 1,300 engines in the market. We already passed the shop test, and we have the first engines coming into operation. And I think that this technology is really the future technology for all the Eckerzone operations. I still have 3 minutes left, not even 3 minutes and 50 seconds, so I would like to pass over to Stefano De Marco because he squeezed in 2 slides. I'm sorry for that, but I promised him to have a word.
Hello everyone, good evening. Just to tell you that as a company together, Wärtsilä and WinGD, we are not, let me say, offering technology devoted to the engine itself, but we are trying to support the customer on all what concern the gas management. So from the bunkering, from let me say from the management of the vessel, of the LNG, the storage, and let me say to supply towards the engine itself. But really concluding is that we are, as a company, not only supply equipment. What we are trying to give to our customer is expertise. We can rely on more than 12 million running hours and several projects that we have studied, analyzed, participated with major classification society. And we hope now to carry on also with the arena in the near future. And I want you to close quoting what Mr. Francioni was telling. It can be for economical reason or environmental. The customer is important that can count on our support. Thank you.
There was another slide, that was this one, huh? You didn't, Nick. Okay. So then I would like to close 2 minutes ahead and hope for you to see you tonight at the dinner. Thank you. Grazie.